Especially you're talking about when you was a young kid, you using the Taiwan.
The pump, yeah, it's still there.
Pumps.
Yeah,
Still there.
everywhere in Taiwan knows what I'm talking about, I think.
Wow.
Yeah, the house was damaged during the earthquake of '98 or something, but it was rebuilt.
So in the middle part of Taiwan.
Yes, Taichung, near Taichung, yeah. And, but when it was rebuilt, they saved the pump. So the pump is not needed anymore, obviously, but still there. As a reminder to the family that this is where we started.
So when will you left Taiwan to America?
5 years old.
5 years old.
Yeah.
Wow.
Yeah. So my father came for the graduate work in the U.S., like many Taiwanese, in the early mid-60s, 1960s. So he went to Taida here, and then I think back then graduate schools were not existing maybe in Taiwan. So he had to go to U.S. to do his PhD.
I know your PhD degree is in the Princeton University.
My undergrad is Princeton. The PhD is in MIT.
MIT, oh, right.
Yeah.
So you have purely engineering background.
Yes, chemical engineering. Yeah.
Chemical engineering.
Yeah, which means I can finally use it.
So you're the expert. No problem at all.
MKS before has some chemistry and process engineering, but now we have a lot more chemistry. So
that's great.
So it was nice to be able to use a lot of my education from a long time ago.
Mm-hmm. First thing I would like to say, congratulations to you. You just received the Pinnacle Awards last month. Yeah. I think this is a very huge achievement for your from your professional life.
Yes, thank you. It is, and also it's maybe partially a recognition of MKS has become a more prominent company. Right. And so we're very honored to have that award.
There's a tiny question I would like to ask. It's kind of personal. Yeah. Right? What's the county you mentioned about the water pump equipment? Where is that located?
Where is the house? My home? Yeah, it's so a long time ago there was a train line from Fengyuan to Dongsi.
So Fengyuan, Dongsi.
Yeah, that train.
Okay.
And we were right next to the train tracks, and it's a small town. The stop right before Dongsi is a small village called Meizi. Meizi, yeah. That's the village that the ancestral home is in. Yeah.
I used to have this kind of water pumping system. Because I was in the Taoyuan County. This is similar like this one.
Yes, they're same. It's same. If you want water.
Still working well.
Still work. Yeah.
Thank you to join this interview. Just would like to ask about the first things is the marketing information about like a PCB market. Yeah. And I thought, because right now the TPCA Show focus on the PCB market, but also they have IC substrate.
Yes.
And for these two markets, they also have another even more bigger potential, which is advanced technologies. Yes, like a heterogeneous integration, so something like that. Yes. So I would like to get your observation about the market. What do you think about the market right now?
Yeah, so it's the most exciting part of the PCB industry. This is the package substrate and heterogeneous integration. So, our view is that we want to be foundational to everything that makes advanced electronics advanced, and that's enabling Moore's Law. And as you understand for sure, Moore's Law was an economic observation that everything gets twice as good every 2 years. And that was true for the first 45 years by just shrinking the semiconductor. So that was the original Moore's Law. And then it started, even as we kept shrinking, we weren't getting 2 times the performance anymore. So Moore's Law started to slow down. And then people said, well, we have to do something. And then that was the era of multi-cores. So people started putting different cores, different CPUs, 2 CPUs, 4 CPUs, or GPUs, but it was still one chip. But because you split up the workload, you can continue this performance. And so it extended Moore's Law for maybe another 10 to 15 years. And then it started slowing down as well. We couldn't divide up the one die into more cores. We've already divided it up to many cores. So then we started integrating multiple chips together. And this is the era we're in, heterogeneous integration. And that is the exciting part of why MKS acquired Atotech. We saw that heterogeneous integration was going to be as important to extending Moore's law as the semiconductor. And I've always said this, the semiconductor is necessary, we have to make it better, but it's no longer sufficient to extend Moore's law. We have to integrate multiple chips together. In order to do that, you have to have an interconnection highway to allow more powerful chips to talk to each other. And that's package substrate. And that's why we're at TPCA. That's why I am at TPCA. It's my first time. Yeah. It's so important to our company. It's always been important to the Atotech brand, as well as the ESI brand, the laser drilling and chemistry equipment. So they've been here for a long time. But this is where we see a foundational inflection that requires packaging as much as chips. And that's pretty different than in the past.
I saw the video you gave the speech for the about 2 weeks ago. This is we talk about two major strategies you have. One is around the wafer.
Yes.
The other one is around they call it workpieces.
Yes.
So can you describe a little bit more about around the work?
Around the workpiece, yes. So when we bought Newport Corporation in 2016, they had 20 product categories because they had done a lot of M&A, 20 at least. MKS had also had 20, but we were surrounding the vacuum chamber for semiconductor equipment makers. So we already had a surround strategy for semiconductor. When we bought Newport, we said, you guys have this, you actually have surrounded the workpiece. And by that we mean any workpiece that you need a laser to do something to it, cut it, modify it, change it, that is the workpiece that we care about. Okay, and if you need a laser, then you need motion, you need optics, you need laser measurement, right? And the laser, of course. So that was the idea of surround the workpiece when we acquired Newport. Then as we moved to packaging with Atotech and ESI, we said, so optimize the interconnect is a subset of surround the workpiece. And so the workpiece now is a PCBA. Yeah? And surrounding it, we have lasers, laser systems, chemistry, as well as chemistry equipment. And so when we say surround, when you make a package substrate or a PCB, our company addresses 70% of all those steps, 7-0, yeah? No other company is even close, not even close. And in addition, we have equipment and chemistry. So very few companies do both. And I believe that having both allows us more flexibility to optimize the next generation process steps. Because we've seen this movie before in semi. It's just 20 years later. And the movie goes like this. As things get more difficult, you need more tools in the toolbox. You need better equipment as well as better chemistry. You can't just get it done with just better chemistry or just better equipment. You need both. And so if you have more tools in the toolbox and you have it all under one company, you have a better chance of helping your customers get to their goal, which is the next generation PCB package faster. And so that's our idea of surround the workpiece, and a subset of that is optimize the interconnect. And if we don't do that, then the industry slows down, right? Because we have to get to these solutions as fast as possible in order to keep Moore's law going. So that's what we mean by surround the workpiece, and optimize the interconnect is a subset of that.
I think you're brilliant. You foresee the market will go to the advanced packagings. Right now, those solutions are very suitable for this kind of advanced packaging solution. But how about the challenge from the industry? How do you think about that?
Yeah, well, no, there are a lot of challenges, right? More layers, smaller lines and feet and spaces and via sizes, integrating glass, right? So we love this because this is our DNA, how MKS operates. In semi, remember Moore's law is twice as good every 2 years. That means the whole supply chain has to continually improve very quickly. And we have structured the company to be an R&D company that moves very fast. And so we like to be in markets that require high technology and move fast. So one of the distinguishing features of semiconductors in the past is that the market requires you to continually be better. Not just be better for a while, but be better forever. Yeah? That's very different, right? Much harder.
Right, much harder.
And we see packaging going the same way. And when you have to be better continuously, only a few companies are structured to do that. A lot of semiconductor equipment companies and process companies. And now I think we will see how many more packaging companies can continue this roadmap. Because in the end, what happened in semiconductors is in the 1990s, there were, remember, 30 chip companies, at least. Now there are 5. Yeah? There were dozens of equipment suppliers. Now there are 5. And there are hundreds of MKSs. And now we're a third of the market. And the reason this consolidation happens is because you need scale to do R&D through cycles.
Right.
Because the problem is harder. The best example is in semiconductors, ASML's EUV tool. It took 20 years. That's a long time. But you had to continually work at it for 20 years before it worked. And that's really a reflection of the market becoming difficult, the technology becoming difficult. So when we hear about challenges in packaging, how do we put the films together with more layers? How do we make the boards bigger? How do we be more productive, faster? We love all that. Those are problems to solve that we think we can be as good as anybody, maybe better than everybody, hopefully. And that's the kind of market we like, a market that requires continuous innovation. Not just innovation once, continuous innovation. And that is a moat around a company. So if you can do that, many other companies can't do that. So you have a differentiation. Yeah.
So we are in the TPCA show. So any kind of exciting technology from your company to showcase in this?
Yeah, well, certainly you have some pictures of some really big tools and chemistries. We also are speaking at the APAC conference here. Lots of technical talks from both our internal research leaders as well as invited speakers. And there we're showcasing a lot of the new chemistries as well as new equipment. Because when you think about the challenges of making smaller lines and spaces and packaging, that's hard to do, right? And drilling smaller holes.
Yeah, that's very difficult.
And the roadmap. There is a roadmap that's very challenging. So some chemistry products that can fill those holes better. There's another challenge, which is that people are talking about glass substrates as a core to provide rigidity to the package. That is a new material for this industry, and that requires different chemistry to be able to fill those holes. The aspect ratio is also very, very high, so it's hard to fill a very large hole very quickly. So that's another exciting new problem, right? Among many new problems. So those are very interesting topics that we will showcase some of our solutions to.
This year, we in Taiwan will look at very exciting information about the AI servers, which is a multi-layer boards.
Yes.
And also on top of the motherboard, you have an advanced chip.
Yes.
Like AI GPUs, which is getting bigger and bigger.
Yes.
And also IC substrate is getting bigger.
Yes.
So those kind of challenges will bump in some problem or challenge, or how do you solve this kind of
Yeah, so one of the biggest challenges is the chips, the AI chips, are getting bigger and more powerful. And there are more of them. And they have to talk to each other. And so our customers are driving a roadmap to make the interconnection package substrate faster and more I/O, more bandwidth. In order to do that, there's 3 things that the whole industry is trying to do. Make the lines and spaces smaller, okay, so you can put more density, but that's not enough. So now we have to put more layers. So 15 layers going to 20 to 25 to 30. And multi-layer boards are even more, right? So I'm just talking about the package substrate. The multi-layer board is sometimes 40 layers now and continuing to grow. So we make the lines and spaces smaller, we make more layers. That's still not enough. People want bigger boards. So you think about it, if I make a bigger board and I have 20 layers to 30 layers, they have to be laminated,
right,
and connected with, and stay connected to each other as the board gets bigger. And there's always some warpage, non-uniformity. And so you have to solve all those problems.
And also the heat problem, I guess.
And heat, yes, exactly. And there are many innovations in the industry. People are, I have a lot of optimism for the industry because, these problems, there's a lot of smart people working on them, including our own engineers. And there are always solutions. I don't see anything as impossible. It's going to be hard work. And maybe that comes from my semiconductor background, because when I started in the semiconductor industry, we were doing quarter micron, not nanometer, quarter micron, so 250 nanometers. And that was, whoa, that's hard. I don't know if we can do this, yeah? And 30 years later, we're doing 2 nanometer chips, right? Very crazy, very amazing. So I've seen what humanity can do when they need to solve very difficult problems as an industry. And I think that the package industry, when I see the show, when I see the TPCA show and all the different companies here, I'm very optimistic that we will solve these problems. It will be hard, and it will be opportunity for some companies as they solve these problems.
I look at the laser drilling system in the video. Yes. Talk about in 1 second can drill about
10,000 holes. Yeah.
So this is for the current situation. But how about the next stage? They talk about, just you mentioned, the glass substrate.
Yes.
That's even more difficult because the material is harder, I guess.
Yes.
So how do you think about, they call it panel level packaging? About
yes.
Is that the good direction for that? How do you think?
Yeah, I think a lot of people have done wafer level packaging, but remember, there's different types of packaging. The whole idea is to get the chip connected to the outside world. So there's the wafer level packaging where the chip is going onto a redistribution layer that goes onto a package substrate. So the redistribution layer, that packaging is more like wafer level packaging. But you're right, everybody's saying wafers are only so big. The chips are getting bigger.
Right.
This is inefficient, not efficient enough. It has worked, but we need to find a more efficient way to do it. So people are moving to panel level packaging of these chips. And there's a lot of momentum, a lot of interest in figuring out how to do that. And really, as Moore's Law is really about economics, this is just an economic driver. How do I make my processes cheaper? And that's why the drive towards panel level packaging. So, in wafer level packaging for MKS, we are involved there. There's chemistry, chip-to-chip chemistry, and RDL chemistry. And we benefit from our semiconductor equipment because a lot of the RDL is still silicon.
Right.
And so a lot of our traditional semiconductor companies who we have great relationships with for 50 years are enjoying that. But for the Atotech chemistry, that is still, while important and growing, a small percentage of the chemistry. Most of our chemistry is in panel level. So if things move from wafer to panel, it's even better for Atotech. So we are very much hoping to help the industry solve this transition from wafer level to panel level packaging. And it will help reduce costs.
I have one poll question about it. They talk about in 4 years, TSMC tried to use the glass substrate panel level packaging in 4 years, next 4 years. Do you think this is possible? TSMC is a very successful company, and they have shown that they can execute incredibly well. So I would never doubt TSMC, but of course we have to get the whole industry, to help support that. I would say this: I wouldn't be surprised, right? And 4 years is maybe plus or minus 1, right? But it's not 20 years. So I think TSMC certainly is a world leader in packaging now, as well as the chip making. If they say we're going this way, there's a whole supply chain that is going to help them do that. Okay. As we talk about a glass substrate, how about they talk about silicon photonics? Yeah. Is that also in the track for your company?
It is, but it's slightly different. So the making of the silicon photonics devices, the transceivers and receivers, we don't do that. That is made by other companies, but they're going to integrate it onto the package substrate. which is what we do, right?
Yes.
Now, I think the real question is what needs to change on the package substrates to allow silicon photonics to be integrated? And I think that's the challenge. But I think there are a few leaders already pushing this, and I think we need it because otherwise in the data centers, the communication is just not fast enough, right? And so, so I think this will happen, but it's really about modifying some layers on the package substrate so that you can integrate silicon photonics into the package substrate. And that's where we can help our customers.
Mm-hmm. Okay. So this is we go through different new advanced packaging technology we have, including the glass substrate, even the silicon optics, something like that. How about the manufacturing side? I know you have a policy called the China Plus One. Actually, everybody has this policy. Something.
Everybody has a China Plus One strategy. Yes.
So tell me more about the strategy you have, the China Plus One.
Yeah, well, there's two parts of it. We continue to invest in China. We're building a new factory in China and a chemistry factory. And so we are continuing to invest in China. China is a big market for us, important customers for us. So we will continue supporting them. At the same time, there is a market need that is causing companies to build factories somewhere, outside China, and many of our PCB customers are building it in countries like Vietnam and Thailand and Malaysia. And so as they move, while we're already there, we are going to expand our footprint in Southeast Asia. So we have already publicly talked about a new factory in Penang. That's a super center. It's a very big factory, but that's more targeted towards our semiconductor manufacturing divisions. But we also announced, I think this week, that we have bought some land in Thailand, Bangkok, because we need to build a chemistry factory so that we can support all of the packaging customers that are moving now to Thailand. So we will do that over the next couple years and also put a technology center there. So many of our factories have technology centers so that customers can develop the next generation products within the country. They don't have to move anywhere. They don't have to ship panels anywhere. We'll have a tech center so they can experiment and co-develop with us. So that's our investments in just Asia, China, Malaysia, Thailand.
I know a lot of PCB makers in Taiwan also moved to Thailand. I think there are 9 or 10 companies there already. So that's going to be huge.
Yes, you're right. There's at least 9 or 10, and maybe 9 or 10 more, all right? And so we are certainly in constant communication with our customers, because we need to support them. We need to have the right engineers to install our tools in Thailand. We need to have the right engineers to service the tools. We need to have the right chemistry applications engineers to work with our customers in Thailand. So we're not only building the factory infrastructure, but also the staff, the human capacity.
So this is the China Plus One. Another news is to talk about they call it robo-taxi.
Robo-taxi?
Yeah, in American, this is kind of it's a mainstream topic. It's very interesting about everybody talking about the automotive market.
Yes.
So and the PCB also have an automotive sector.
Yes.
So how do things go on in the automotive sectors?
Yeah, I think automotive is certainly a sector that's integrating more and more chips. The number of chips, the content of chips in automotive is continuing to really grow very quickly, driven to your point by autonomous driving or even just assisted driving. And also EVs have a lot more electronics in them. And so, you kind of look at an automotive trend, it's kind of like a smartphone on wheels now, right? It's a lot of chips, very smart, a lot of data talking to each other, a lot of calculations, right? And this is just beyond the infotainment, right? This is actually the controlling of the car, the running of the car, optimization of the car. And so we've always been in automotive PCBs, and we see this continue to grow. So it's a great opportunity for us. So content of chips in automotive is a driver for the PCB industry as well as the semiconductor industry.
Right. So those kind of directions would be help the industry to migrate to the next stage, I think.
Yes. I think there's a lot of tailwinds that are going to help not just the semiconductor industry, but the PCB industry. Automotive you talked about, but really data centers and AI for data centers. And our view too, by the way, is AI is incredibly important right now, but I take a longer term view of AI because it's really Moore's Law. That's the thing that ties all of it together and that enables something like AI. So the concept of AI, large language model, that's not new, right? It's just that the computing power needed was too expensive, so it was not possible. But as Moore's Law continues to progress, things get cheaper every 2 years, right? Twice as cheap. Wow. At some point, something that requires a lot of computation that you couldn't afford 5 years ago now becomes affordable, and suddenly you have AI. But if you think about going back in history, for me, when I was in college, one of the biggest changes is that I left after the second year for the summer, and when I left, the computer room had terminal and nothing else. Just a connection to the supercomputer at the university center, one computer, right? And I come back for the third year, and the room is different. It has monitors with little boxes. And so what are those? That's the PC. This is 1983, yeah? Personal computer. And if you think about when 500 years from now, when we're writing the history of humanity this time, it's debatable whether the most important thing was the PC, because everybody can have one. Think about that. That's a big change for mankind. And then everybody can carry one, a laptop. Then everybody can carry one in their pocket phone. And then everybody can carry one in their pocket and talk to anyone and get any data, the data center, the internet. And then AI. I can actually get more efficient with that data. So I think, though, it's quite significant that every human being can own a PC. That is a maybe bigger deal than AI. Maybe. I don't know. But it's certainly, AI is just the next big thing in a history of many big things. But the fundamental drivers, we kept Moore's Law going.
It's very interesting. We have covered all the topics. My last question for you, because you already have a very tight connection with Taiwan. So last question for you is what's the message for Taiwan?
Oh, well, I was born in Taiwan, so I'm very proud of what Taiwan has done. As I said in my speech, when I left Taiwan, it was a third world country, right? There was no technology. There was no grad schools, so my father had to leave. So you think about what's happened in Taiwan in the last 50 years, amazing. Taiwan is now home to the most advanced chip company in the world. No dispute, right? No one disputes that. And of course, the PCA industry, many of the leading companies are Taiwan-based, right? They've moved beyond. They have factories worldwide now, but the headquarters are Taiwanese-based. And so I would just continue, number one, congratulating Taiwan for this accomplishment over the last 50 years. Very few countries have done this. And then, of course, I look forward to the future. And I can see everything that Taiwan is doing now is going to continue propelling them to be leaders, not just in semiconductors, but also in packaging.
Thank you very much.
Thank you very much. It's very nice talking to you. Yes. Okay. Take care.